let's track this wire. So we have here 19 volts. So we have here this path means goes directly to here. Why? Because we have the path, as you see. We follow this path. So 19 volt goes to this capacitor, to this MOSFET, as you can see. To this MOSFET, as you can see. Okay. Also, we have this diode, as you see, D21, also is connected to this MOSFET because we have the same path. Let's check. As you can see. Okay. Then this diode here is connected, as you can see, to the ground. Then here, if you focus here, as you see, we have the drain. This is the drain because all these 4 pins are connected together, and also here we have the drain because these 4 pins connected together. So let's check these pins. So let's check this. Okay. So we have the second, the third, the fourth. Also these pins, the second, the third, the fourth. And also all these pins, these 4 pins are connected to this. Why? As we see, because here we have the same color, the green color. All these 4 pins and these 4 pins are connected to this green color, means this is the same path. But for example, for this MOSFET, as you can see, we have here 3 terminals connected together with the same color, but this one, no, this one is connected to this bus, means this is the gate. Hi, we're going to see how to track motherboard signals. We're going to see the motherboard's path and buses. We're going to see and study many circuits in the motherboard. I'm going to teach you how to track signals and then how to repair motherboard without using schematic. You will be able to track any signal in the motherboard without schematic, just by following and tracking the buses. First steps before diving into understanding how to track signals and voltages in the motherboard. So you will find always the motherboard with many parts, or we have this part here, and we have here a path or a line, and we have here another path, as you can see. So this path is not connected with this. Okay. Here also this color means another part. And of course this hole, as you can see here, or this color, this also, okay, as you can see, and those also here, all these are ground. Also this is ground, this is ground, this is ground. Also this is connected to the ground. Okay. Then as you can see here, we have this lines or path. I'm going to show you how to use this path. Even if you don't have a circuit diagram or the schematic of the motherboard, you can understand the motherboard using just this paths. As you can see, there is many differences and many shape of this path or lines. This, for example, hold a very low signal or a very small signal, maybe 0.5 volt, for example, or 0.2 volt. But for this, for example, is very thicker, is thicker than this, is thick or bolded. This can hold 3.3 volts. Okay, but for this, for example, this wire can hold 19 volts. Here also, as you can see, we have here many paths or line or motherboard inductors. Okay, as you can see also here, all these are paths or motherboard conductors. As you can see, this is buses, or we can see buses. Okay, so as you can see here, the same principle. As you can see, do you see these buses or motherboard lines? Okay, do you see this? This, and we have other here. For this hold a very small voltages, but for this it can hold, for example, 19 volts or more. Okay, as you can see, we have here other lines or buses. Okay, as you can see here, for this IC we have these buses in this IC. Each pin is connected to a component here. If we check the continuity between this pin, for example, we will find this pin with this capacitor is connected together. Okay, so if you understand how to use these buses, you can troubleshoot any motherboard without its schematic. Okay, I will show you in the next lectures how to use this path and buses to troubleshoot the motherboard and to track the signal. Okay, as you can see here also, do you see all these buses here, also here? So let's track some buses and path in this motherboard. So let's begin, for example, here. As you can see, this is the processor, okay, and this is the CPU circuit, the processor or the CPU. So this is the CPU circuit. As you can see here, we have here coils. This is inductors. We have here some MOSFETs, as you can see. We have here some ceramic capacitors or PF capacitors. We have also here a chemical capacitor. Okay, so if we focus here, if you focus here, you will find here we have many buses and many paths. So let's begin from this capacitor, as you can see. So here it seems that here we have the positive side because this is chemical capacitor. So here we have plus and minus. Why? Because we have here this mark here and this line over here. So this is plus and this is minus. So the minus of the capacitor, of the ceramic capacitor, is always connected to the ground, as you can see. So this is the minus, as you can see. If we follow this green color means the same path, the same line, as you can see. If we follow it, as you can see, here we have the ground. So the ground is connected to this terminal of this capacitor. Let's check using the multimeter. So we should just put the multimeter to the buzzer option, as you can see, and let's check. So let's put one probe here in this multimeter, as you can see, and put the other in the ground. Do you hear the buzzer? Means continuity. Okay, so this part is connected to this. Of course, as you can see here, also this MOSFET, as you can see, we have here 3 terminals. Okay, because here we have this point here and this mark here means this is the first pin of this MOSFET. First pin, second and third. So this is the source of the MOSFET. These 3 pins should be connected together, as you can see. So let's check these 3 pins. As you can see, these 3 pins, as you can see, are connected together and also connected, as you can see here, this is connected to the ground. You know why? Because as you can see, the same color here to the ground. And also, as you can see, this ground, as you can see, if we follow this bus, the big bus, connected also to the source of this MOSFET. So let's check, as you can see. Okay, connected to this, and connected to this MOSFET, and also to this capacitor. Why? Because we have this part here, this green part, as you can see. But is not connected to this, because we have here another bus here. Okay? So, as you can see. So here, so we can check this from here, as you can see, to the capacitor here, as you can see, the same connection. Okay, so let's check, let's follow also this path, as you can see. So this is the ground, so it is connected to the ground here, and also goes where? It goes to this capacitor. Okay, so let's check this capacitor from here to ground, as you can see, and also to here, the same. So all this parts here, this green part here, means ground. If you found if we find any component connected to this part, means connected to the ground. As you can see, we can follow it. As you can see, we can follow this part, as you can see, and go here. Also, this is part of ground, okay? And also, this is ground, as you can see, okay? So here we have this capacitor here. So this capacitor have to be connected to ground, as you can see. So let's check. Do you see? Because its terminal is connected to this green color. Okay. And also, as you can see here, if we follow this ground, as you can see, goes also here, as you can see. Okay, and also here, etc. Okay. Now let's check some small buses, okay, that hold signals. So let's check, for example, this. As you can see here, we have these buses. As you can see, this is a bus. This is a bus. This is another bus. Okay, this is other buses, etc. So if we focus here, as you can see, let's focus with this bus, for example, this bus. So here we have chemical capacitor, as you can see here. So with this terminal, as you can see, let's follow this bus. As you can see, goes directly where? So goes directly to this resistors. So let's check using the multimeter. So let's check the continuity. The continuity is good. So let's check from this capacitor, as you can see here, to where? To this resistor. As you can see, we have continuity. Okay, we have continuity. Why? Because I know how to track the signal. So you can use the schematic to know that this small capacitor is connected to this small resistor over here by tracking this path, as you can see, or by using the schematic. But for me, I can track signals in the motherboard without schematic, and I will show you in this course how to track signals, how to track voltages in the schematic without, or in the motherboard without using the schematic. Okay. Of course, the schematic is very important, but if you don't have, you can do your troubleshoot and repairing without any problem. Okay. So let's continue. So let's check also this, the second bus. So we check this capacitor. Let's check this capacitor also. So let's put the first probe here in this terminal, as you can see, and then track it and follow this. As you can see, goes to this resistor, as you can see. Do you hear the multimeter? So this resistor over here is connected to this chemical capacitor. Okay. So here we have a connector, as you can see here, and we have some part that is access to this connector. As you can see, we have 1, 2, 3, and we have the ground here. Okay. So let's check this 3 or 4 buses. We have the first one, the second, the third. Here we have the fourth. So all these fours are goes to these resistors. Means these resistors are connected to this connector. Let's check. So let's check this. So we have here the first pin. So let's put this in the first. So this first bus goes directly to this resistor. Let's check. Good. We have continuity. So let's check the second. So normally should goes to this. Okay. Let's check the third one. So the third one should go here. Okay. So let's check the fourth one. As you see, the fourth one goes here. Let's check. As you can see. So this connector, the signals that goes to this connector should pass through these resistors. Means if you have problem with this connector, what you should first check. Of course, you should check first the connector. Is it bad or not? The soldering, is it good or not? Etc. First the connector and also the pins. Are the pins good or damaged? Etc. The second thing to check, what is this resistors? Why? Because this resistors is connected directly to this connector. Okay. That's why you should check this resistor. But without knowing about buses and how to track signals, you cannot imagine that these resistors are connected to this. Okay? So for here, as you can see, what we have here? We have, as you can see here, the power check. So here we have a 19 volt. Here we have the red wires. Here we have the black wires. Means in these two terminals, we will get 19 volt. And of course, for the black terminals, this is connected to the ground, of course. So always put the multimeter to the buzzer option, as you can see. Okay? And check the continuity. So the continuity is good. And check whether these two are connected to the ground. Should be connected to the ground. Why? Because we have here the black wire. So let's check it. Also the second is connected to the ground. Okay? But for the red wires, of course, this is a positive wire or the high wires. So let's check this. Let's track this wire. So we have here 19 volt. So we have here this path means goes directly to here. Why? Because we have the path, as you see. We follow this path. So 19 volt goes to this capacitor, to this MOSFET, as you can see. To this MOSFET, as you can see. Okay? Also, we have this diode, as you see, D21, also is connected to this MOSFET because we have the same path. Let's check. As you can see. Okay? Then this diode here is connected, as you can see, to the ground. Then here, if you focus here, as you see, we have the drain. This is the drain because all these four pins are connected together. And also here we have the drain because these pins, these four pins connected together. So let's check these pins. So let's check this. Okay. So we have the second, the third, the fourth. Also these pins, the second, the third, the fourth. And also all these pins, these four pins are connected to this. Why? As we see, because here we have the same color, the green color. All these four pins and these four pins are connected to this green color. Means this is the same path. Okay? But for example, for this MOSFET, as you can see, we have here three terminals connected together with the same color. But this one, no. This one is connected to this bus, means this is the gate. These three are connected together. So let's check the first, the second, the third. But this, no, it is not connected with these three. As you see, here we have this signal. This is the gate. Okay, this is the gate. Okay, here we have the control signal. The control signal pass through this bus. And here we have source. Of course, here we have this point, this dot. And this mark, this means this is the pin number 1, 2, 3. This is 3 are source. This is the gate, as you see. This is the control signal. Here we have the drain. Okay. So these points here means this source is connected to other components in the back side, in the other side of this motherboard. When you find this point or this dot like this, means this source is connected to 1, 2, 3, 4, to 4 components in the other side of the motherboard. So let's check the other side of the motherboard. Let's check exactly these 4 dots. We will find these 4 dots near to these 3 dots. As you can see, this is 4 dots. As you see, this is the 4 dots. next to this 3 dots. So this 4 dots, as you see, goes directly to this. So this, okay, is connected to the MOSFET. As you can see, we have 4 dots, as you see, goes to this. So this is connected to the MOSFET. And then, as you can see here, we have here other dots. We have 1, 2, 3, 4, 5, 6, 7, 8. We have here 8 dots, means this is a resistor. A current sense resistor is connected to 6 components in the other side. As you can see here, we have 6 points. These points are not connected to this green color. No, as you see, we have here a circle. Means there is no connection between this point and this, because this is the ground. As you can see, okay, this is ground. So this point is connected to the other part in the motherboard. These parts are 6 circuits in the motherboard. So for this IC, for example, so this is the audio IC. As you can see here, we have the audio jacks, okay, and this is the IC that controls the audio. This is the Azalea codec that controls the audio. So as you can see, if you focus here, each pin here is connected to a component. As you see here, each pin here is connected to a chemical capacitor. So without using the schematic, if you focus in this IC, you should, for example, in this pin, as you can see here, this pin is connected to this chemical capacitor. Why? Because we have this bus here, over here, and this is the test point. This, if I put the probe here and in the terminal, as you can see, if I put the probe here, as you see, with the multimeter and the other in this terminal, as you can see, we hear the buzzer, means we have here continuity, means this point is connected to this. Also this is connected to this, as you can see, okay. And also we have here a chemical capacitor, means this chemical capacitor is connected to this pin, as you can see, okay. The same for this, as you can see, goes to this, and this, as you can see, okay. So without checking here, because if you try to check something here, you will make a short circuit and then you will damage this IC. So avoid to take measurement or here, because you can make a short circuit in this IC. For example, if you want to check between this pin and these 2 pins, you can just go here to this chemical capacitor and to this chemical capacitor and check, for example, the voltage between these 2 pins, for example, okay. Also, as you can see here, the same working principle also here, okay, and also in here, as you can see, for example, as you can see, okay. The same for every IC in the motherboard. Also this IC, also all its terminals or pins are connected to other components around this IC, okay. The same for this IC. For example, this is clock generator. Always the clock generator, you will find a crystal oscillator, as you can see. So as you see, all these terminals are connected to other components. So let's see another motherboard. So as you can see here, we have another motherboard. So let's see the circuit, okay. So here near to the power jack, as you can see, this is the power jack. So let's track the signals here in the circuit, or the buses in the circuit. So as you can see here, for example, as you can see, if we focus in this, as you see, we have here the power jack, we have here 2 MOSFETs, and here we have a coil, okay. If you focus here, for example, we have here this MOSFET is connected to this MOSFET, as you can see. Why? Because here we have the same color. Here we have drain, and also here we have drain. So this 4 pins is connected also to these 4 pins. If we can check using the multimeter, so let's put the multimeter to the buzzer option, as you can see here, and then press the power button. Okay, so for now let's check the continuity. As you can see, so this MOSFET, all these pins are connected together. So let's check first the continuity. So let's check. As you can see, all pins are connected together, as you can see, and also these 4 pins are connected to these other pins, as you can see here. Okay, so after that, the other pins of this MOSFET, as you can see, this MOSFET is the Q4. As you see, if we track the bus, as you see here, we have the green color goes directly to this resistance, as you see, this 15 ohm resistance, and also here we have coil. This means that this MOSFET is connected to this resistance because we have here same color. Okay, as you can see this. So let's check using the multimeter. If we put one probe here, okay, and check here, as you can see also the coil. Okay, so after that, the signal or the 19 volt will pass through this resistance and go where? As you can see, we have this green color here. No, it will go to this capacitor. This capacitor is connected to this resistance because, as you see, we have the same path here, the green color, and also will go here, as you can see, and to this transistor and to this diode. Okay, without using the schematic, I can know that this diode is connected to this. Why? Because we have this path or bus, as you see, the same path. So let's check also using the multimeter. So let's put one probe here and put the other here, for example, in this transistor, as you can see. Do you see? Also here, do you see? Also this diode is connected to this resistor. Okay. And of course, because this resistor, this is a current sense resistor, it is like a fuse. We can, if we put the probe here in this diode, as you can see here, in this diode, okay, and go, as you see, connected to this and connected also to this coil, and of course to the MOSFET, as you can see. Okay, why? Because here we have the same path. Okay, and also here, if you focus here, we have this MOSFET also, we have source here. This 3, also this 3 pins connected to this diode. Here we have the same path and connected to this transistor, and of course connected to this, as you can see. So let's check also this. This is the source of this MOSFET, the same path, so it will be connected to this transistor, and if we go here, as you can see, connected to this, also will be connected to this capacitor. You know why? Because we have here the same path. Okay, so let's see the circuit. For example, here we have the GMCH circuit. Why? Because here we have the processor. Near to the processor we have the GMCH, as you can see. So this is the GMCH power management. Here we have coils and we have, of course, some MOSFETs. So if you focus here, for example, as you can see here, we have these 2 MOSFETs are connected together, as you can see, because we have here the same color, the same path. So here we have point, means this is source, these 3 are source. If we check these 3, as you see, let's check the continuity first. These 3 are connected together, as you can see, so let's check it. Okay, and this also. Okay, this is the gate, of course. Do you see the gate? The gate is not connected with the source. Here we have a green color, here we have another color, here we have the same color, green color. So means these 3 are connected. We have here source, we have here drain, and here we have here source and gate, and here we have drain. As you see, 4 pins connected together, and the drain of this is connected to the drain of this. Because here we have the same path, as you can see. We can check using the multimeter, of course, as you can see. Okay, and then here, as you can see, And here, if you look here, you will find that the source of this MOSFET, if we follow this path, as you can see, is connected. As you see, just here we have this path, follow this path, goes to here. So this coil should be connected to the source, as you can see. Why? Because we have the same path here. Okay, so let's check for this, for example. So here, as you can see, we have the clock generator. Always the clock generator. Near to it we have a crystal or a quartz. As you can see, always here we have a small buses. As you can see, all clock generator pins are connected to other components. For example, let's check, for example, this resistor. As you can see, we have here a tin bus. So let's check this. Resistor is connected to this pin, as you can see. Why? Because I follow this bus. Okay, so let's check, for example, this resistor, as you can see, is connected to what? To this pin here, the second pin. Okay, but for this, for example, here is connected, as you can see here, is connected to the pin number 4. You know what? Because we have here buses. I followed just buses without using the schematic. Okay, and you can use a technique here. If you want, for example, to test between two pins here, avoid to take test here or measurement here, because you can damage this IC if you do a short here. You can look for the extension of this pin. For example, for this pin, its extension is this resistor. So I will put one probe here, and the extension of this pin, for example, is this resistor. I will put another here. Okay, so always try in the ICs that contain a pins that is near to each other, use the extension to take a measurement. Okay, so let's check over here other tanks. So as you can see here, for example, for these two capacitors, as you can see here, these two capacitors, this is a chemical capacitor. These two capacitors, as you can see, are connected together because here we have the same color, as you can see. And also this color also connects this coil to this capacitor, as you can see. Okay, the same color. But the color is not connected to this. As you see here, we have a circle of another color. It means, okay, it's not connected to the capacitor. Okay, so in the other side, this capacitor, as you can see, for example here, if you focus here, this capacitor in other side are connected together, of course, and connected, as you can see, goes and connected to this resistor here. As you can see, if we check, do you see? Connected to this resistor, because we have this part and then we have this small part here. Do you see here in the motherboards, all these are buses. Okay, all these are buses. You can use these buses to know the connection between the component. For example, if you look to these two capacitors are connected together, as you can see here. These two capacitors are connected together. Why? Because we have this bus here that connect between this. Let's check these two capacitors. Let's check this. So let's check this capacitor. Okay, as you can see, we have a continuity bus. Why? Because we have this bus. So I know that these two capacitors are connected together directly from the motherboard without using the schematic. Why? Because I know how to use the buses. So the buses is a circuit in the motherboard. All these buses, you can use all these buses. Okay, all these are buses. Okay, all these are buses, exactly like the schematic. The wire in the schematic, okay, also this buses means like the wire in the schematic, as you can see here. Okay, as you can see. For example, you can follow this bus, as you can see here. For example, we have here a bus. You can follow it like this. From this point goes to this point. Okay. When you find a point like this, means this bus goes to the other side of the motherboard. Okay. Do you see here? You see here we have a big bus. This can take 19 volts, as you see. From this point here, as you can see, goes directly where? To this point here, as you can see. Okay? We have here this IC, as you see. Do you see the extension here? So avoid to take measurement here, because you can do a short circuit. But if I want to take measurement, for example, between these two, I can look for the extension of this pin. This is its extension in this resistor. We can check, as you can see. And for this, its extension is here. Okay? For this, its extension is here, because these two pins are connected together, as you can see. Okay? If you look for this diode, for example, because here we have diode, do you see this path or this terminal of diode? As you see, connected to this point here, because I follow this bus. Okay, so this resistor, as you can see, this small resistor here, do you see it? Is connected, as you see, if I track this to this point, as you can see. Okay, I have here a continuity, but you cannot imagine if you don't have the path here. You cannot track where this resistor goes. Okay, and if I see the other side of the motherboard, I can't find this point in the other side of the motherboard. So let's check. As you can see, we have the point here. Okay, so this point goes where? So goes to this resistor, as you can see here, and also goes here to this VGA connector. Okay, if you have problem with this VGA connector, as you can see, you can check this resistor, because this resistor, as you can see, connected to this point and then this point to the VGA connector. So if we put one probe here and check here, we will find a continuity in one pin of the VGA connector, as you can see here, as you can see. This, because this resistor is connected to this point, and then this point in the other side connected to this pin here. Okay, so that's why you should understand how to track signals. For example, this diode also is for the VGA connector. You know why? Because we have this path here. This diode is connected to this path, as you can see here. Why? Because we have this path or this bus, as you can see here. We have this bus here. Okay, and then in the other side it is connected directly to this resistance. Why? Because I have this path also here, and then this resistor or this capacitor. Okay, here if you focus here for this port, this is an old port, a parallel port. Here we have many capacitors, as you see. This capacitor, for example, is connected to this point and also connected to this pin. For this, it is connected to this pin. This for this pin, etc. As you see, this is extensions. Okay, for those also. Here, for example, we have this MOSFET. So this MOSFET, all these are the same path. I can automatically understand this. These two capacitors are connected together. Why? Because we have the same color here, same path, and also this capacitor is connected to this MOSFET, as you can see. Why? Because we have the same, as you can see, path. But this capacitor are not connected to this. Why? Because we have here another color, as you see here. We have here a bridge, another color. Okay? And this is the gate. The gate is connected directly to this point, but not connected to this. Okay? And here, for example, what we see here, these two capacitors are connected together, as you can see. Why? Because we have the same color, and also connected to these 2 points, as you can see. And here, from here, this capacitor is connected to this diode. Why? Because we have the same path. This diode here, this is the plus or the anode, and here we have the cathode, is connected to where? To this MOSFET. Why? Because we have the same path, as you can see. Same path. This MOSFET is connected to this capacitor, as you see. The source evidence of this MOSFET is connected to this capacitor. Okay? For example, for this diode here, this diode is connected to what? To this? No. Here we have a bridge or another color. Let's follow this, as you can see. So it is connected here to the drain of this MOSFET, because we have here the same color, same path. Okay? But for source of this MOSFET, it is connected to this capacitor. Same path. Okay? So this is how you can track the signals. So I want to add that, of course, using the schematic in the troubleshoot is one of the very important things that every technician can need during repairing. But if you understand the steps that I teach you in this lecture and in the previous lecture, and also I will teach you in the next lecture, you can troubleshoot, locate and repair any motherboard without any schematic. You can just use the paths or the bases, as you can see here, that is drawn or designed in the motherboard, and you can understand easily the components that are connected to each other and the other components that are not connected to each other. Okay, so in every circuit you can know the connection or the relation between components using just the buses. Okay, this is an electronic board. So in every electronic board you will find this path, as you see here, like all this. So this path means conductivity. For example, let's take these 2 points. So this point and this are connected together. Why? Because we have here a path that connects this point to this point. So if you use the multimeter and choose the continuity option, so you will get a buzzer or a continuity between these 2 points. Also, this point here, as you see, is connected to this because we have here the path here. But this is not connected to this, and this is not connected to this. Okay? So this is the electronic path. If you understand how to use these paths, you can easily troubleshoot and identify the failure in every motherboard. As you see here, the same principle. As you see, so this point is connected to this and is connected to this. The same here, as you see, all these 4 points are connected together. Okay? Also here, this is connected to this and to this and to this. But pay attention, this point is not connected to this point. Even if these 2 points are close to each other, but there is no connection. Okay? But this is connected to this and to this also, but these 2 also is not connected together. Okay? For these 2 points are connected together. Okay? So I teach you these secrets because this is the most important things that every technician and every beginner in electronics should know. Okay? Because these astuces will help you understand any electronic board and then troubleshoot it and identify the problem. So for example, if we take this point is connected to this and to all these points that exist in the same path. Okay? This is another image of the electronic path. This is the working principle of electronic path. So every board, electronic board, is based on this architecture. Okay? All these are paths, and this is terminals. So this path has two terminals, this point and this point. Okay? So please pay attention. So when you measure and you test every board, every electronic board or computer motherboard, before start to measure or to test a component or a path, you should first pay attention to the solder. Okay, so for example, this is a good point, a good solder, a good soldering. Okay, this is a good solder. As you see, there is no dry, but for this we have a dry. This we call this in electronic a dry. Okay, so now with this dry, this pin or terminal of this component is not connected to the motherboard. Okay, because we have here a dry. So this is a bad soldering. You should pay attention to this. If you find like this problem, it is recommended to remove this old soldering and to place another soldering, because this is the majority of electronic issues in the motherboard and electronic boards are due to this problem, to soldering dry. Okay,